everyone, we're going to find the area of the region bounded by the given curves y equals 2x minus x squared and y equals x to the power of 4. The first thing we want to do is find the intersection points of the curves. And that means we're going to set our curves equal to each other. So we're going to have 2x minus x squared equals x to the power of 4. We're going to try to find our intersection points. And let's write this as x to the power of 4. And then we're going to have plus x squared minus 2x equals 0. And then we're going to factor out an x. Get x cubed plus x minus 2 equals 0. We can't really factor this, so a good way to factor this is to let this equal, and I'm going to ignore this x for now. So I can write x cubed, and what I'm going to do is I'm going to add x squared minus x squared. That equals 0, so I'm not changing it, but I'm going to put x squared minus x squared. And then for this x, I'm going to write 2x minus x, because that equals x, which is not changing it. So I'm going to put plus 2x minus x. And then subtract the 2 equals 0. Now regrouping this, I'm going to get x cubed plus x squared. I'm going to put this one here, 2x, and then minus x squared minus x minus 2 equals 0. Then we're going to do a little factor by grouping. So for this piece here, I'm going to get x times x squared plus x plus 2. And for this piece, you're going to get minus. So change all the signs here, x squared plus x plus 2. All right. So this piece here, since these are the same quantities here, we can write this as x minus 1 by grouping times x squared plus x plus 2. All right. Now setting this to 0, and don't forget I kind of left that out, so that x goes there. So our intersection points are going to occur at x equals 0 and x equals 1. This one we can't factor, and we'll just keep going until you can't factor it. But those are the two intersection points. And that's going to be our upper and lower limit. So now let's look at the graph. We can sketch this graph very easily. So basically this is x to the power of 4 is that quartic function. I'm going to kind of make it bigger than it has to be. I'm just doing a little sketch here. And then this one here is if you factor out an x, you're going to get 2 minus x. So basically we have intersection at 2 and 0. So it's going to go up, and in the intersection points, let's put this at 1. Let's see, I'll move 2 down a little bit. So here's your intersection point here. So it kind of goes like this, comes down like that. All right. So basically this is your shaded region that we're looking for. Now to set up the integral, we're going from 0 to 1. So we're going from 0 to 1. And you look at this upper portion of the curve. So this upper portion here is what you put first. This upper portion goes with y equals 2x minus x squared. So we're going to write 2x minus x squared. And then the lower portion of the curve goes with this x to the power of 4. So you subtract x to the power of 4. All right, dx. Now this graph was fairly easy to graph. Sometimes the graphs aren't, so there's another way you could have done this. You could have set 2x minus x squared and set it greater than or equal to 0, and also set x to the power of 4 greater than or equal to 0. Now that we have our intersection points from 0 to 1, you can test a point in the middle, say 1/2, and see which one's bigger. So if I put 1/2 in this equation, I get 2 times 1/2 minus 1/4, right? So 1/4. So this is going to be 1 minus 1/4. This equals 3/4. If I put 1/2 here, I'm going to get 1/16. Since 3/4 is greater than 1/16, and this one came from this equation, that's the one you put first, the one that's greater. And that way you're always not having to draw the graph. Anyway, that's just a little side note there. Now let's go ahead and simplify this. This is going to be, we can just leave it like that if you want. Since we have this, we can write this as, this piece here is just going to be x squared, minus this piece here is going to be 1/3 x cubed, and this one's going to be minus 1/5 x to the power of 5, and we're evaluating this from 0 to 1. We only have to look at the 1 because the 0 is just going to zero this out. So that's going to give you 1 minus 1/3 minus 1/5. And then you still have this minus big 0, which we don't have to worry about that. Our common denominator is 15. And so that's going to give you 15 minus 5 minus 3. And that equals 7 divided by 15. And so that's your area. Thank you. Have a nice day. Bye-bye.